Hello children, welcome to Right Tuition Classes. We are doing Icse Physics Chapter 2, Exercise 5B Numericals. Okay children, please pay attention. We start with it now. Something very simple children. Two bodies of equal masses. Question number 1. Two bodies of equal masses are placed at heights h and 2h. Find the ratio of the gravitational potential energies. Two bodies of equal masses. Mother, two bodies are there. So what I do, I always have one vague idea. Always name it like this, two bodies. Okay, let me call it body 1 and body 2 of equal masses. Oh, the masses are equal. The mass is same. Mass is same. And how are at heights? Oh, this body is at a height h, then this body is at a height 2h. Find the ratio of the gravitational potential energy. So I want ratio of gravitational potential energy. You know what is gravitational potential energy? U. U1 upon U2. Gravitational potential energy is represented by letter U. So gravitational potential energy of body 1, I take it as U1. Gravitational potential energy of body 2, I take it as U2. What is the formula? mgh1 upon mg what is the height of the first body, children? The height of the first body is h, whereas height of the second body is 2h. So in place of h, you get 2h here. So what will happen, children? M and M gets cancelled, G and G will get cancelled, H and H will get cancelled. So what is left with? Therefore, U1 upon U2 is equal to 1 upon 2, children. So what is the ratio of the potential, gravitational potential energy in volts? The ratio of gravitational potential energies, potential potential energies is 1:2. Got it, children? So I hope everybody's understood this first sum. We go to the next question, children. Question number 2. Find the gravitational potential energy of 1 kg mass kept at a height of 5 meter above the ground if g equal 10 meter per second squared. Please have a look at very simple sum, children. What is the first step? I told you, whenever you read a sum, first write it in notation form. Find the gravitational potential energy, matlab U nikalna, of 1 kg mass. So M is 1 kg, okay? Kept at a height of 5 meter. H is 5 meter, okay? Above the ground, G equal 10 meter per second square. Okay, we have kept all this. And they want me to find U. U is equal to mgh. Please here, U stands for gravitational potential energy. So U equal mgh, so U equal 1 into 10 into 5, children. So U is 50 joules, okay? Capital J. Got it? 50 joules. I hope people understood me. A very simple question, children. Very easy question. Okay. We go to the next sum, children, now. A box of weight 150 kg has gravitational potential energy 14,700 joules. Find the height of the box above the ground. So first thing, again, I told you, children, better write everything in notation form. Okay. Like you see, a box of weight of the box, okay? What is weight of the box? Actually, weight of box is given as mg. Actually, the formula should be, that is given to as 150 kgf, okay? Now, I told you 150 kgf is a gravitational SI unit, but we'd like to know, have it in SI unit. So weight का newtons होता है, ये 150 into 9.8, g का value 9.8 they give. So I keep it like this. I don't multiply, it becomes Newton, okay? This is the weight of the box, okay? Then they are giving the total potential energy U is 14,700 joules. And they want me to find the height of the, naturally, children, height का कुछ formula नहीं, लेकिन ये U का formula है, okay? Gravitational potential energy. So U is equal to mgh, children. So U is 14,700. This mg, if you ask me, 150 into 98 upon 10, that is 9.8. I just write it like this, into h. So now what will happen, children? 14700 into 10, the whole thing divided by 150 into 98. And so easy this is, 0, 0 cancel. Okay, now 49 twos are 49 300s are. Got it? 15 ones are 15 20s are 2 ones are 2 10s are. So H is 10 meter. H is 10 meters. So what is the answer, children? The height of the box above the ground, height of the box, height of the box above the ground equal 10 meter. This is the answer. You should better make an habit of writing an answer, children. Okay, we go to the next. Question number 4. A body of mass 5 kg falls from a height 10 meter to 4 meter. The body was initially at 10 meter. Now it has fallen to 4 meter. Calculate the loss input. Naturally, from top, it has come down. Earlier, it was here, okay? And now it has come here, and this is the ground. So earlier, it was here, and now it has come here. So naturally, this body has lost its kinetic potential energy. Got it? So that is what they want, loss in potential energy. And then the total energy possessed by the body at any instant. So listen, what I'll do is a body of mass. First, I'll write everything in notation form. A body of mass 5 kg. Okay. Was at a height of 10 meters, fallen from a height of 10 meter to, so H1 is 10 meter, and initially it was at H1, and it has fallen to a height of, what you can say, 4 meter. Got it? They want the loss of potential energy. So simple, children. The first one, loss of potential energy equal, loss of potential energy equal mgh1, the initial potential energy, minus the new potential energy. Okay. So what will happen, children? I'll put mg common. So if I take mg common here, inside a bracket h1 minus h2, and now I'm going to put the values. This is loss in potential energy. It's not energy. Okay, how much, what is the loss? Okay, so m is 5 into value of g is 10. Value of g is 10 in the sum. They given the value of g as value of g as 10 meter per second square. So this is 10, and it has fallen from a height of 10 meter to 4 meter. So this is 5 into 10 into 6. So this becomes 300 joules. So this is only a loss in potential energy. Now, what is the second part of the question? The total energy possessed by a body at any instant. I mean, this is, please here, the total energy possessed by a body, total energy possessed by a body at any instant is equal to potential energy of the body on top, potential of the body on top, potential energy of the body at top, okay, maximum height, that is at maximum height. What is that? mgh1. So m is how much? Children, 5. What is G10 and what is H1? 10. So it was 500 joules, okay? It was maximum height, is maximum energy possessed by it is 500 joules, okay, children? I hope everybody has understood it. Calculate the height through which a body of mass 0.5 kg is lifted if the energy spent in doing so is 1 joule, okay? Calculate the height through which, see, and calculate the height through which a body of mass 0.5 kg, mass 0.5 kg, okay, is lifted. Calculate the height to which a body of mass 0.5 kg is lifted. If the energy spent in doing so is 1 joule, so energy, see, calculate the height, matlab, through which a body of mass 0.5 kg is lifted. Mass is 0.5 kg, the energy spent in doing so, energy spent in lifting, energy spent in lifting, okay, is equal to 1 joule. Now, what is G value? 10 meter per second square. And they wanted to find H. Got it? Height through which it is lifted. See, remember, energy spent is nothing but work done. Work done. Energy spent is nothing but work done. Work done का formula है बेटा. In case of lifting, example the mgh. Therefore, don't you agree now? 1 joule is equal to m is how much? 0.5. G is how much? 10 into h. So 1 is equal to 0.5 h. So 1 upon 5 is equal to h. So h is equal to 0.2 meter. So calculate the height through which the body is lifted. So height through which the body is lifted equals 0.2 meter. A very simple sum, children. Question number 6, children. A boy weighing 25 kg, the weight of the boy is 25 kg. He climbs up from the first floor at a height of 3 meters above the ground to the third floor at a height of 9 meters above the ground. What will be the increase in his gravitational potential energy? So simple this question is, okay? So what is the first thing what you do is we write everything in a notation form. Okay, so boy weight. So weight of the boy, weight of the boy. So if the boy wants to climb, the minimum force he has to exert is equal to its weight. Got it? So that he can go up. Okay, so 25 kg is equal to 25 into 10. How much you get, children? 250 kg. G is 10 here. G is 10 Newton. 10 Newton per kilogram. Okay, so naturally 250 Newton. Therefore, mg equal weight of the boy is mg. Therefore, mg equal 250 Newton. The weight of the boy is given by the formula mg. Mg equal 250 Newton. Now, what is the h1? 3 meter. What is he climbs to h2? 9 meter. So increase in gravitational potential energy will be bigger gravitational energy upon smaller gravitational energy. So mgh2 minus mgh1, mg common, h2 minus h1. mg is given directly 250, h2 is 9 minus 3. So how much you get? 250 into 6, it will be 1,500 joules. What is the increase in gravitational potential energy? Increase in gravitational potential energy equal, what do you get, children? 1,500 joules. Got it? So answer, increase in gravitational potential energy, increase in gravitational potential energy is equal to 1,500 joules. Okay, children. Now we go to the next one. Question number 7, children. A vessel containing 50 kg of water is placed at a height of 15 meters above the ground. assuming the gravitational potential energy at ground to be zero, what will be the gravitational potential energy of water in the vessel? See, mass of the vessel with water mass is 50 kg, okay? And it is at a height of 15 meters above the ground, right? And G is 10 meters per second square. So naturally, when they say gravitational potential energy of the vessel, gravitational potential energy of the vessel is equal because it is at a height of gravitational potential energy of water. Gravitational potential energy of water in the vessel. Of water in the vessel. Is equal to mgh. Got it? M is how much? Beta 50. What is G? 10. And what is H? 15. So 23, 7,500 joules. The gravitational potential energy of water is 7,500 joules. Okay, children? A very simple sum. I hope people are understanding. So simple, children. You can see here, what is the mass of the man? 50 kg. Okay? He climbs up a ladder to a height of 10 meters. And what is G? Value of G is given as, okay, 9.8 meter per second square. Okay? So G is 9.8 meter per second square. Now the question is, work done by the man. Work done by the man. Work done by man. Please keep it in mind. You know, force into displacement. The force he has to use will be equal to his weight. Okay? Climbs up. Okay? So it will be equal to mg. And the displacement is height h. Okay? Now, what is this values? 50 into 9.8 into 10. Okay? So how much it becomes, beta? It becomes 50 into 98. So what is this? Multiplying by 15, multiply by 100 and divide by 2. So it becomes 4,900 joules. The work done by the man is equal to mgh. Okay, increase in his potential energy. The second part, this is the first part. The work done by the man the increase in potential energy of man will be equal to the amount of work done. Amount of work done by the man. Okay, so how much it is? 4,900 joules. Okay, 4,900 joules. Now I go to the next sum, children. A very easy sum. A block A, one can see a block A weighing 100 Newton. What is the weight of this? 100 Newton. Is pulled up along the slope by a length of 5 meters. But is pulled up along the slope of length 5 meters. It's pulled up, okay, along the slope by length 5 meters, okay. Oh, by mistake I wrote 550. It should be 5 meters, okay, 5 meters. By means of a constant force F of 100 Newton. Definitely. See, if the weight is 100 Newton, the force, minimum force has to be applied will be 100 Newton only. Got it? So weight of the block A, kitna diya beta? 100 Newton. And even the force applied is 100 Newton. Okay? And it moves a distance 5 meters on top. So the first part, A part of the question is, okay, what is the work done by force F? So work done by force F. Oh, by force F is equal to F into S. F is 100 Newton. S is 5 meter. So it will become 500 Newton meter. Got it? Now what is increase in potential energy of block A. So the block A gets lifted by vertical height H equal vertical height H equal how much? 3 meter. So increase in potential energy equal mgh. M is how much, children? This is 100 into 3. It is 300 joules. Now C part is the most interesting question. Account for the difference. See, if the potential energy when it comes here, if the potential energy is 300 joules a day, but actually when you lift it from here, 500 work done was 500 joules. So all that 500 should have stored in the form of 300 joules. लेकिन ऐसा नहीं हुआ इसका जब भी when this block A was pulled the work to this point okay top the work done was 500 joules okay equal 500 joules but what happens children okay but the vertical height I calculate 3 meter only so I calculate the potential energy increase in potential energy is only 300 joules so actually 500 joules work किया गया but the energy that gets stored is only 300 joules तो ये क्या हो गया 200 joules का so account for the difference in the work done by force and increase in. See, so what happens? Some part of the energy, some part of the work done gets used up in overcoming the forces of friction. Hence, forces of friction. Correct? Some parts of work done gets used up in overcoming the force of friction. Hence, increase in potential energy is only 300 joules. Correct? So 9 sum over children.